Hi, today we need to take a look at what it's going to take to actually work on that palindrome checking algorithm that we were talking about. Now, we have some tests inside our unit test file that gives us information as to what we need to do, so we need to make sure we have a palindrome. And again, as a reminder, when we're talking about palindromes, a palindrome is a word or phrase that when you start at this end and read it left to right, it's the same as if you start at this and read it from right to left. And so you've got things like race car, famous one, able I was, ere I saw Elba, for another, talking about Napoleon, of course. And then you've got other just simple ones like ABBA, the band. Ooh, yes, I know. But we want to be able to have a way that we can actually solve for this and make sure we can make it work. So we're going to start off, of course, we have the header of our method has already been determined by our unit test. It tells us what we have to have the method called. So it's a public Boolean method because it returns true or false. And it's called check palindrome, and it takes a single string as a parameter, whether or not it is there. And so I just named it text because text is a great name for a string, just to talk about that. And because we want to have a compilable structure the entire time we're working with this, we immediately turn this into a stub. So the first thing we do is we declare a variable of the type that we're working with. In this case, it's a Boolean. I call it isValid because it's a great name for a Boolean variable. And I assign it the default value of false. And then at the very bottom of my method stub, I have return isValid. So immediately I have compilable code that will automatically fail most of the tests. But that's okay. It compiles and it runs, which is what we're looking for. Now, as we talked about in class, when we're working actually putting together a solution for this, we've got a couple things we need to make sure we do. And the first thing we have to make sure we look at is we need to make sure that we don't get extra spaces in the front and the end. And I had you search inside the string API for a method to identify what that was. And again, that method is what? I know no one's here, but it's the trim method. And so trim takes all the extra spaces off the front and the end of a string and removes them. But because strings are immutable, you can't change them, we have to make sure we use that and assign it to a new value. And one of the things we always want to talk about is when we're talking about a parameter or data that's passed to us, we don't want to destroy the original value unless we're explicitly told to. So we're not going to destroy the text parameter that's given to us. Instead, we're going to apply that trim method and remove the spaces from it and store it in a new variable that we can use inside the method itself, a new local variable. So what we'll do the first thing after we do this is we'll just make a new variable right here that we can hold that in there. So we'll make a string variable. And I'm going to call it, well, tested, because that's what we'll work with in class. And so it's called tested. And tested is a string. And we're going to assign it the value of text. We're going to take that parameter that we are given, and we're going to put it inside this tested variable, but we're going to also apply the trim method at the same time. So I'm going to do text dot trim. And so the trim method, again, remember it takes all the extra spaces, that's including tabs, invisible characters besides the space, anything that's at the front and the end that doesn't belong to actual regular text, wipes them out, and we're going to store it in this new tested variable. So now we've got tested, we still have a compilable stub, nothing's going to happen to our code, we're good to go. Our next step is we want to make sure we exclude palindromes that are just too small. The empty string, nothing, well, it is a palindrome because nothing forward is the same as nothing backwards, but that's not what we're looking at. So we want to exclude that. And because of the test that we have installed in class, I also say that a single letter like the word A or I doesn't count. In fact, this double sequence like LL, BB, CC, DD, whatever, or two emojis together, that doesn't count as a palindrome either because it's just not cool enough. We want to make sure we do that. So instead, after we do that trim, we want to make sure we return appropriately, saying, hey, we're not looking at things that are too small but could potentially be in a palindrome. So the next thing we're going to do is we do a check for that. And the way we check anything using computer science is with the magic power of our if block. And so we have an if right here. And inside the if block, we want to check to see how long it is because we ask a string its bigness. And so if tested.length, and because we're using strings, not arrays right here, we use parens at the end of that. So if tested.length is less than 3. So if it's too small, so it's 0, 1, or 2 in length, we don't want to even bother with it. So at that point, right here, we're simply going to return isValid. We're going to return immediately out of our method. We don't want to test anything else. So we'll just have an if block right here, and inside the if block, it's just going to be return and isValid. So that immediately gets us out because we don't want to even test anything at that point because why bother checking past that? We've already done all the work, so we just simply return. We leave at this point. We know the answer. We don't want to look at any further. Now, this will only give us correctness if we have a palindrome that's not true and it's smaller than 3, which that's only like 1/3 of the question. We now need to look at all the different pieces of the string, one letter at a time. But again, I've got my amount of board space, but I don't want to lose my logic right here. So again, just like you're doing this if it was on an AP exam or a written test, we're going to just go ahead and draw a lovely arrow over here and go to the other screen. Ta-da. So we've got this new space we can write. We're going to continue on. We are going to leave it off with that return is valid, so we've got that right there. But we're going to continue writing our code right here so we can keep on with this. So if you run out of space ever, you always have more ways you can keep on writing, use extra paper, etc. to make that happen. All right, so now that we've done that, we have to look at all of our different letters one at a time. And again, last time we had you review the string API, and there is a way we can actually look through one letter at a time using the string API, and that's the power of the substring method. The substring method has two different versions. You have substring with one parameter and substring with two parameters. The one parameter goes from here all the way to the end, and that's not really that helpful. But the substring with two parameters, I can get a start index and an end index, and I can do that and grab one at a time because of index and index plus one will give me one letter. But wait, I don't want just the one letter. I want to make sure I match it also to the end letter. And so to do that, I have to make sure I can figure out what that last spot is. So say, for example, I have over here, I have the word first. Zero, 1, 2, 3, 4. So we have the word first right here, and in the 0th index we have F, then I, then R, then S, then T at sub4. And this right here is at the length minus 1. So that's at length minus 1. So to get that, if I start at length minus 1 and then length, that will give me that letter. Oh, so I have length minus 1 and length to get me the last letter, and I have index and index plus 1 to get me the 0th letter, and that gives me the first and last, and that's great. But then I need to make sure it moves in and in. So if I have that length minus 1 minus index, and then length minus index, so I always just make it keep going back like that, I can grab the last letter moving in this way, because the subtracting index moves it towards the middle, and the index going up with the loop makes it go that way, and they get together, squish, 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 and they can meet in the middle, and we have that match right there, so we can test this against this against this. Obviously, first, not really a palindrome, so not very the best example, but it gives us the logic. So we need to make sure we can make a loop that can go from the beginning to not the end. We only have to go, we don't have to go to the middle. Oh, because I already can calculate the endpoint using dot length. So let's go ahead and do that. Let's make a for loop that can make that happen. So we have a for loop. And inside the for loop, we'll start with int index, just like always. And again, I like to use words rather than simply single letter variables, because by using a word, we can always keep track of it up in our head better, and we don't have to worry about what if, say, we have a more complex iteration or something like that, we get something confused on that. So int index will always start off at z, or 0, and we're going to index is less than, and we don't want to go all the way through, we're going to go to the halfway point, so we're going to do the word, which is tested, dot length, parens, and then we're going to grab that length and we're going to divide it by 2 because we only got halfway through it. And then, just like always, index plus plus. So we now have a for loop that can go through and get every single letter. So now what we need to do is we need to get the first and the last letter of where we're at the time. And those are, of course, strings because we're doing strings one at a time. So we'll have a string, and I'll call it first letter. And it's going to be equal to tested. Actually, scratch that. So we have our first string first letter, and we'll have a string last letter. And we need to assign to those that information we just talked about a minute ago. We have to get the first letter and the last letter mathematically. And again, because the substring with the 2 parameters, we pass it an index and index plus 1 to get one letter at a time. And so index right here starting at 0 will automatically give us our first one, plus 1 will get up to there, which is great because the first one is inclusive, the second parameter is exclusive. But to go to the last one, we have to go to length minus 1 and then comma length to get that. So inside our first is going to be tested. Dot substring, and we'll pass it index, and then index plus 1. Now, we don't want to do plus plus right here, because if we did plus plus, that would add to the index variable. We don't want to hurt index. We've got to screw everything up and make it all be messy and yucky. Ugh, no. So we first get our first letter, and then we want to go ahead and we assign our last letter. Again, we're going to work with tested. That's the trimmed off version we were working with. And again, we're using substring. And this time, though, in substring, instead of starting at index and index plus 1, we need to ask it for the length spot. So I'm going to put right here, I'm going to go to get the tested dot length. And then that gives us that big number, but then we have to minus 1, because we want to go back, because we have to remember we have to go back before it. And then minus the index, where I'm starting with right here, so I can make sure I shoot in each time. So minus 1 minus index for the first part, and my second parameter is just going to be tested dot length minus index, because that's going to be one more than that, because again, remember, we have to always go one more than that to get that inclusive value, because again, if we just did the same value of right here, just give me nothing, and that's not going to help us. We have to go one greater than this, so that's why I don't have the minus 1 in the second parameter, and I go right there. And now I want to go through and I need to compare these two. Now there's multiple ways to compare strings. Inside my version of this algorithm, we don't care about case, so we're not going to use a case structure. So we can either force these all to be lowercase, force these all to be uppercase, or we can use the magic of the equals ignore case, which we're going to work with today. And so we're going to go if, and then parens, and we're going to do a not right here, because we want to make sure if we don't have a match, we don't want to do anything. So if they don't match, we're going to leave again. So if we don't match, and we'll have last letter dot equals ignore case, and we're going to pass it as a parameter first letter make sure parens match, which they do. And so if they don't match, again, we're going to return is valid because we're done. We don't need to do anything. Now, I like to use a variable for my return statements, like I've said before, because that way I can always mentally track where I'm at and what's inside it, and I haven't done anything to change is valid from false. So it's good right there. So is valid is still false, so I'll just return is valid. So as soon as I have a bad answer, I'm out. And that gets me through all of the stuff right there. So I'm inside my for loop. I've checked every single letter going doot, 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 doot. And even if it's an even number or an odd number, it doesn't matter because I keep going squish, squish, squish. And if I get to the same letter itself, this letter and this letter are the same, so no big deal because, again, I don't have halvesies. So I get out of that. And if I make it all the way through and I never returned is valid, that means it matches. So now I'm just going to say is valid equals true. And that means I'm back over here, make an arrow, back over to here. Again, in case I run out of room, I've got that right here. I ran out of room because I've got a big whiteboard. I'm trying to make sure you can read what I'm writing on this. And so I start off with the is valid is false. I make sure that I get rid of the blank spaces at the front and the end. I then check to make sure it's not too short because I don't want to have a tiny thing because that's boring. And then I come back over here. I look at all of my letters one at a time using the substring logic we talked about, where I get the index and index plus 1 for the first word, and the last letter of the word is dot length minus 1 minus index, comma, dot length minus index. So I squish in each time as I go through that. I then check to make sure they match, not worrying about case, using equals ignore case. And if I return is valid at this point, it means it's false, it doesn't match, because I have that not operator right there to negate my logic. And finally, if I make it all the way through the for loop, I matched all the letters, they're all good to go, we're good. I assign is valid to be true, and I come back again, and I return is valid because I've correctly determined whether or not that this palindrome is in fact a palindrome, or that string in fact is in fact a palindrome. And we've got a match right there. So that's how we can do this, to write a method that can go through and do that. Hope this is helpful in helping you figure out how to use some logic and working with strings and string methods. There's other ways to do this, including using the dot split method so you can get each letter at a time and look at them as array contents like that. Or you can even use dot compare to and do some cool things with that. Great options to do some more solutions, or even using string builder. Hope you have some fun. Have a great day. Cheers.